Hey everyone, this is Mr. Morris again, continuing the answer keys for the summer homework. This is in the Chapter 3 summer homework on stoichiometry, number 31. It's kind of a tricky question because we're involving more than just your typical stoichiometry. We actually have density in this. So let's talk about it real quick and we'll kind of go through how to think about the question. It tells us some information. In the laboratory we can make small quantities of hydrogen peroxide using this chemical reaction. And it asks us what amount of hydrogen peroxide. I'm going to assume when it says amount it means mass. Just going to assume that. Okay, should result when 1.50 grams barium peroxide, so that's this one, BaO2, is treated with 25.0 milliliters of hydrochloric acid. Now milliliters, it's not mass, it's a different unit, but it gives me this information. Hydrochloric acid solution contains 0.0272 grams of HCl per milliliter. So these units, grams per milliliter, I hope you recognize that's a density unit. Okay. So before we actually do anything else with it, we need to turn that density into mass. So we need to find what mass we're talking about. So and you can work that up here if you want. You can work it wherever you want to. I'm going to go ahead and just set it up here. So it's given me the volume of HCl. I know the density. That's grams per milliliter. Okay. The mass I do not know, and the volume is 25.0 milliliters. Okay, so then I need to solve for that. Okay. So density equals mass over volume. I've got 0.0272 equals m over 25.0, right? And I could cross multiply so that m, the mass, and this is the mass of hydrochloric acid. Just remember that's what we're looking for. The mass of HCl that I'm going to get can be found by multiplying 25 times 0.0272. So if we do that, 25.0 times 0.0272, you get 0.68. That's my mass, so I'm going to say grams of HCl. Okay, and then I'm going to plug that in. It's getting a little crowded, but we can handle this. Okay, so that's my grams of HCl. Now what we taught you is that we need to have units of moles up here, don't we? Okay, so I'm going to take that 0.68 grams of HCl and I'm going to convert it to moles. So I've got to have my molar mass on the bottom and 1 mole on top. Okay, so we're going to find that molar mass. HCl, hydrogen is 1.008, and then Cl 35.453. Okay, I get 36.461. That's my molar mass. Okay, and that is going to find the number of moles of HCl that I put right there. So let's start by doing that. 0.68 times 1 over 36.461, and you get 0.018. It's actually 187. but I really should round that to 0.19. Okay, so let's change that to 0.019 moles of HCl, and I'm going to put that right here. Okay, next thing that we want to do, and I'm going to switch colors for this because it's just going to get really crazy if I don't, is I need to turn the barium peroxide into moles too. So I'm going to start by, I'm going to do that right here, 1.50 grams of BaO2. Again, we're converting to moles, so I need to have my molar mass on the bottom. Find barium on the periodic table and find oxygen. So barium, oops, almost lost my calculator there. Barium has a mass of 137.328. Okay, and then oxygen is 15.999. But we gotta have 2 oxygens, so we're gonna multiply by 2. We get 169.326. Okay, so I'm going to do 1.50 times 1 over 169.326. And I'm going to get, I need to keep 3 sig figs, so 0.00886 moles. Okay, and I'm going to put that number on top of barium oxide, or barium peroxide. Okay, so I've got this many moles of barium peroxide and this many moles of HCl. Remember, what we put on the bottom is just the coefficient, so I have 1 mole of BaO2, and I have 2 moles of HCl. So now what I need to do is find what I'm looking for, which is the mass of hydrogen peroxide. What I'm actually looking for is hydrogen peroxide, so all I can really find from this is moles. X mole over 1 mole. Okay, so let's start by doing, I'm just going to do the one that's on the left, so I'm going to start with 0.00886 moles of BaO2 over 1 mole of BaO2. Now, since it gave me 2 reactants, the amounts of 2 reactants, I know this is a limiting reactant problem. So my first step is actually going to find out just how many batches of the reaction can I do. How many times can I do this reaction with 0.00886 moles of BaO2? And then I want to do the same thing with HCl. So if I divide that, I'm just going to get 0.00886, and my units cancel out, so this number doesn't have a unit. It's just telling me how many times I could do the reaction if I tried to. Okay, and then I'm going to do the same thing with the other reactant. So with HCl, I have 0.019. I don't know if you can see that. Let me move my paper a little bit. Yeah, 0.019 moles of HCl over, and we have 2 moles in this case, 2 moles of HCl. And if I put that in a calculator, it's going to be a little bit less than 9, right? Or a little less than 0.00, a little more than 0.009. Okay. Yeah, so 0.0095 is what I get. Alright, so in one scenario I say I could make this much. In the other scenario I say I can make that much. The limiting reactant concept is that whichever one I run out of tells me that's the limiting reactant. So it looks like I'm going to run out of barium oxide. That's what I'm going to use. This is my limiting reactant. That's my limiting reactant. And as it turns out, this is my excess reactant. And let's be really specific. The excess reactant is HCl. It's not this number, it's HCl. And our limiting reactant is not this number, it's BaOH2. So we want to make sure we're being specific about that. In stoichiometry, you always use your limiting reactant when you're solving the problem. Okay, so I've got it now. I just need to find out how much H2O2 I can make from it. So I'm going to draw a line here because I'm dividing my work to the other side. Okay, so I have 0.00886 moles of BaO2 over 1 mole BaO2 equals X moles, I'm just copying from up here, of H2O2 over 1 mole of H2O2. Okay, so X over 1 is X, right? And 0.00886 over 1 is 0.00886 moles. Okay, so that's how many moles of BaO2 I have. I still need to turn that into grams. Okay, so now that I've got the number of moles, I'm just going to take that number and that's actually moles of, I guess we need to write that down, make sure that we got it correct. This is moles of H2O2. Okay, so if I have moles of H2O2, I'm going to cancel out moles on the bottom. And then on the top, I need to have grams of H2O2. Back to our periodic table again for that. H has a mass of 1.008, but I'm going to multiply that by 2. So 2 times 1.008 plus 2 times, and then oxygen is 15.999. I have 34.014. I just realized I'm writing and you can't see it. I hope I didn't do that for too long. Okay, 34.014 grams of H2O2. All right, so now what we want to do is multiply 0.00886 times 34.014 divided by 1. Okay, that gives me the answer. I need 3 sig figs, 0.301. Okay, I don't have much space here, but I guess I can write the number 0.301. I'm going to write the units under it. It's grams of H2O2. Check your problem, make sure that you answered the question. Okay, what mass of hydrogen peroxide, it says amount, I'm assuming mass, should result? Did I answer that? Yes, I did. This is mass. Grams is a unit of mass. Okay, I know this video is getting kind of long, but we've got one more step we need to do, but it really doesn't take that long as long as you understand it. Okay, so it asks what mass of which reagent is left unreacted. Okay, so which one is unreacted? That's another way of saying which one was in excess, which one did not totally react. We had some extra, some leftover that wasn't used. Okay, so in other words, we're going to take our excess reactant, we need to know what that is, it's HCl in this case, and instead of it being 0.019, I'm going to change that and make it my new X. Okay, going to start by finding moles, and then we'll convert to grams because it's asking for grams. Okay, so I'm just going to use my limiting reactant like I did before, but I'm doing x over 2 to find how many moles of HCl we're actually reacting. Okay, so first we got to find out what reacted, then we subtract to find what the reaction, how much was unreacted. So we start out 0.00886 moles of BaO2 over 1 mole BaO2 equals, all right, and then I'm going to put x moles of HCl over 2 moles of HCl. Okay, now I can cross multiply. X times 1 is x equals 2 times 0.00886. And I get 0.0177. And that is moles of HCl. Now, is that the moles that didn't react or the moles that did react? It's the moles that reacted. Okay, those are the moles reacted. All right. Well, I need to turn that into grams because it asks about mass. So I have 0.0177 moles of HCl. Need to turn it into grams, so I'm going to have 1 mole of HCl on the bottom, and on the top I'm going to have grams of HCl. We need to look at our molar mass. I had already found it up here, so I'm not going to solve that again. My grams of HCl are right here, 36.461. Okay. In the calculator, if I go like that, I get 0.6453, so 0.645, 0.645. My units are grams of HCl that are reacted. So unreacted, how would we find what's unreacted? Well, we want to find out how much we used, and then we want to find out how much was available in the first place. So this is what was used. What was available? Well, we found there were 0.68 grams of HCl available, right? This is what was available. So I'm going to take the amount that was available, 0.68 grams HCl available, minus the 0.645 grams that reacted, and when I do that, so we end up with 0.04 grams unreacted HCl. And that's the answer to the final question. I know this one took a little bit longer to do. I wanted to make sure I was explaining everything clearly. It's a two-step problem, but I think the tricky thing is just that you've got to go from density to mass and then convert from mass into moles. You've got two reactants, so you've got to find which one is the limiting reactant. Go with that. And once you get used to limiting reactants, the rest of them are not so hard.